Hello there. This presentation is about engine values, AIC, BIC, log likelihood, and Wald statistics values in data analysis. What is engine value? Engine value and their corresponding engine vectors are fundamental in linear algebra that have significant application in statistical analysis, particularly in multivariate statistical analysis. The origin. The concept of engine value originated from the study of linear transformations and matrices, which were formalized in the late 19th century by David Hilbert and Hermann Weyl to suit many fields, including statistics. Engine values are crucial in data analysis, particularly in fields like statistics, machine learning, and dimensionality reduction. Some key points and components of engine values are as follows. Dimensionality reduction. Engine values are fundamental in techniques like principal component analysis, where they help in identifying the directions, principal components that capture the most variance in the data. Higher engine values correspond to directions with more variance. Data interpretation. Engine values provide insight into the structure of the data. For example, in PCA, a large engine value indicates that the corresponding component explains a significant amount of variability, helping to identify important features. Stability and sensitivity analysis. In systems analysis, engine values can indicate the stability of a system. For instance, in control theory, the sign of engine value can determine whether a system will converge or diverge over time. Clustering and classification. In special clustering, engine values of the Laplacian matrix of a graph help to identify clusters in the data. This technique leverages the geometric properties of the data. Feature selection. Engine values can assist in a feature selection by indicating which features contribute most to the variance in the data sets, allowing for more efficient modeling. Now let us look at the components of engine values. What are the components? Engine value, that's the engine definition. Let's see what the engine engine value is all about. Engine definition. An engine value is a scalar associated with a linear transformation represented by a square matrix. 2. Engine vectors. What are engine vectors? Each engine value is associated with one or more engine vectors. These vectors represent the directions in which the data stretches or compresses. Now, characteristics polynomial. Engine values are found by solving the characteristic polynomial, which is derived from the determinant of the matrix A, lambda, where the equation is the identity matrix. The roots of this polynomial are then what we call the engine values. Multiplicity. Engine values can have algebraic multiplicity, that the number of times an engine value appears in the characteristic polynomial, and geometric multiplicity, that's the number of linearity the number of linearly independent engine vectors associated with an engine value. Now, special decomposition. A matrix can often be decomposed into its engine values and engine vectors, allowing for transformations and analysis of the data in a more manageable form. In summary, engine values and the potential, in summary, engine values are potential tools in data analysis that enable the understanding, transformation, and interpretation of complex data sets. That is the reason why I'm putting out this. Let me come again. In summary, engine values are potential tools in data analysis that enable the understanding, transformation, and interpretation of complex data sets. Their role in dimensionality reduction, stability analysis, and feature selection makes them indispensable in various analytical frameworks. So that is about engine value. Now let us look at what AIC, BIC, log likelihood, chi-square, and Wald statistics are in research. Now, what is AIC? Okay, AIC is simply means AIC information criterion. What are the uses? The AIC information criterion is used for model selection. If you have so many models, or you develop so many models, then for you to be able to select a model, then you use the AIC and information criterion or the Bayesian information criterion. So it's used for model selection among a set of models. It helps to identify models that best explain the data while penalizing for complexity, that is number of parameters. Now, the interpretation. Lower AIC values indicate a better fitting model. When comparing multiple models, the one with the lowest AIC is preferred. The difference in AIC, that is denoted by delta AIC, can indicate relative model performance. Now, let us now go to the twin, which is the BIC. What is the BIC? BIC simply means Bayesian information criterion. What is the use? The Bayesian information criterion is similar to the AIC. BIC is used for model selection, just like the AIC, but it imposes a heavier penalty for model complexity. It is particularly useful when the sample size is large. So when the sample size is large, it is better if we use the BIC to make our selection. Maybe when it is a little bit, when the sample is not so large, you can make use of AIC. But both of them penalizes, for something, for model complexity. But the BIC penalizes more for model complexity than the AIC. Now, what is the use? It is particularly used when the sample size is large. Now, what are the interpretations? Like the AIC, lower BIC values suggest a better model. In general, BIC is more conservative than AIC, and it favors simpler models as sample size increases. The model with the lowest BIC is always preferred. Now, having done with AIC and BIC, now let us look at what the log likelihood is all about. Log likelihood. What is it used for? The log likelihood measures how well a statistical model explains the observed data. How well. It measures how well a statistical model explains the observed data. We use this log likelihood more in DOLS. We use it in ARDL, and we also use it in panel data. So, and then we equally use it in structural equation modeling. So now, the interpretation. Higher log likelihood values indicate a better fit of the model to the data, while log likelihood alone isn't used for model comparison. It can be used in conjunction with AIC or BIC. So having done with that, now let us look at what the chi-square values and Wald and structural equation tests they are all about. Now this chi-square values is different from the one we use in measuring, the other chi-square used for opinion polls. Now, what is the chi-square used for? The chi-square statistics is used in tests of independence and goodness of fit tests. It assesses whether observed frequencies differ from expected frequencies. Interpretation. A higher chi-square value indicates a greater discrepancy between observed and expected values. The significance of the chi-square statistics is assessed using a p-value. A small p-value, typically less than 0.05, suggests that the model does not fit the data well. A small p-value, typically less than 0.05, suggests that the model does not fit the data well. It's very interesting. Now, Wald statistics. Wald statistics is used to test the significance of individual coefficients in a regression model. It assesses whether a particular predictor significantly contributes to the model. Interpretation. A large Wald statistics often compared to a chi-square distribution indicates that the coefficient is significantly different from 0. A small p-value associated with the Wald statistics suggests that the predictor is significant. Interpretation summary. Now let us look at what we have done so far for what we have just mentioned. Now, for AIC and BIC, lower values indicate better model fit and less complexity. But for the log likelihood, higher values indicate better model fit. Thus, it means that the log likelihood is the opposite of BIC and AIC. So it means that when you are using the three of them, or BIC and the log likelihood, or AIC and log likelihood, that they must go in different directions. And that's what it means. They must go in different directions. So for you to know that it has measured what it's supposed to measure. Now, that's for log likelihood and AIC and BIC. Then for chi-square, higher values indicate profit, and then the magnitude of significance is assessed via the p-value. And for Wald statistics, larger values suggest significant predictors, and the magnitude of significance is always assessed via the p-value. So in practice, these metrics are often used in combination to provide a robust analysis of model fit and effectiveness. You have to understand that if your model is well fit, then you can be proud to use, and you can be very rest assured to use the value that you find out, from your analysis to represent, to make conclusions that will actually stand the test of time. So that is exactly the essence of this video. Thanks for watching, and if you have any question, you can always throw it through the YouTube channel. Thank you.